This is activity number 1 for lesson B-13. For this activity, you will need the assembled Raspberry Pi setup from previous activities, 11 short male-to-male jumper wires, 2 long male-to-male jumper wires, 3 1000 ohm resistors, the RGB LED, and the 74LVC245 level shifting integrated circuit. In this activity, you will install and connect the level shifting IC, connect its output to a GPIO input, and build an RGB LED circuit. You will also build a small program to test everything out before adding the IR sensors in the next 2 activities. The circuit for this lesson will be made of almost entirely different components from previous lessons. The first step is to make sure the Raspberry Pi is powered down so you can remove any components from previous lessons. Remove all components from the breadboard except for the wedge and ribbon cable. When completed, your breadboard should look like this. Next, add 3.3 volt power and ground to the P1 side buses. For 3.3 volts, connect a short jumper wire between A1 and P13. For the ground connection, place a short jumper wire between A5 and N15. You'll now add the current limiting resistors for the RGB LED. You'll be using 1000 ohm resistors to reduce the current flowing through the RGB LED, as the LED elements are already very bright even with the small amount of current allowed by the 1000 ohm resistors. Place the first 1000 ohm resistor in D24 and F24. The second resistor in D26 and F26. And the third resistor in D27 and F27. Now these resistors have to be very close together due to the length of the legs of the RGB LED, so be sure to inspect the legs of each resistor closely to ensure no legs are touching any others before proceeding to the next step. You are now ready to add the GPIO output wires that will drive the red, green, and blue elements of the RGB LED. Connect 3 short jumper wires between these points. To connect GPIO 13, add a short jumper wire to C17 and C24. To connect GPIO 19, add another short jumper wire to B18 and B26. And finally, to connect GPIO 26, add a short jumper wire to A19 and A27. It's now time for the RGB LED and its common cathode ground connection. Remember that all color elements of your RGB LED share one cathode or ground connection, so it only takes one ground connection for all 3 colors of the LED to have a path to ground. The longest leg of the RGB LED is the common cathode. Insert the common cathode leg into J25, making sure to rotate the LED so its anode legs connect to J24, J26, and J27. Next, install the ground connection for the RGB LED by inserting a short jumper wire between breadboard points N125 and F25. Next, the level shifting IC needs to be installed so you can convert 5 volt signals down to 3.3 volts, making them safe for the Raspberry Pi GPIO pins. The level shifting IC has 10 pins per side, so it can be a little difficult to get properly aligned, but make sure all pins are properly aligned in the breadboard before applying pressure across the top of the IC to seat all of the pins. The IC's pins are very thin and can easily be damaged by improper insertion into the breadboard. If you're at all unsure about this process, please watch the video on the Level B resources page prior to attempting installation. With pin 1 located at E32, insert the integrated circuit across the center of the breadboard in rows 32 through 41. Install 4 short jumper wires between the following locations to supply power and ground to the IC. Connect 3.3 volts with a jumper wire placed between P131 and A32. Connect 3.3 volts with a jumper wire placed between C32 and H32. Connect ground by adding a jumper wire to N141 and A41. And finally, connect ground with a jumper wire placed between C41 and H33. The IC is now connected to power and ground, and it's been configured to accept 5-volt inputs on the A side and output 3.3 volt signals on the B side. Next, make 5 volts available on the P2 power rail so it can be used to test the level shifter as well as power the infrared sensors that will be added in upcoming activities. Connect a short jumper wire from J11 to P23. You're now ready to connect an input and output channel to the level shifter. The input of the integrated circuit will float when not pulled up or down. You will use a 10,000 ohm resistor between the input and ground to ensure that the integrated circuit sees a low unless we pull the input high using a connection to 5 volts. Place a 10,000 ohm resistor in N133 and B33. Connect the output using a long jumper wire from I20 to I34. Connect the input using a long jumper wire from C33 to P237. The input to the level shifter will now be held high by a direct connection to the 5-volt power rail. When disconnected, the pull-down resistor will take over and the input will be grounded. Double check all your connections and then power on your Raspberry Pi. It's now time to write a program that will change the color of the RGB LED based on whether the level shifter is receiving a high or a low. Open Thonny and create this new program. There are no new concepts in this code, but here is an overview of everything happening in the program in case you have any questions. The rpi.gpio and time modules are imported. A variable called RGB is created that contains all output pins so they can be set up using only one line. The variables red, green, and blue are set equal to the GPIO pin numbers that control each of these colors in the LED. Color names can then be used throughout the program instead of the GPIO pin numbers. The GPIO pin numbering is set to BCM. Each of the pins listed in RGB is designated as an output, and pin 21 is declared as an input. The try except format is used to catch keyboard exceptions, and a GPIO cleanup runs if an exception is encountered. The try loop uses a while true loop to keep checking the input over and over. If the inputs on GPIO 21 is low or false, then the green element will turn off and red will illuminate. The else condition will trigger if GPIO 21 is high or true during a check. In that case, the red element will turn off and the green element will turn on. The time.sleep command is added to slow the loop checks down to avoid unnecessary checking of the GPIO, which can lead to unnecessary load and heat on the processor of the Raspberry Pi. Okay, go ahead and run the program. The LED will initially be green to indicate that GPIO 21 is high or 3.3 volts coming from the level shifter IC. Carefully disconnect the jumper wire at location P237 and the input will go low, indicated by the LED turning red. Reconnect the jumper wire to P237 and the LED will change back to green to indicate a high is present on the input. Remove and install the connection at P237 a few more times to ensure the program and circuit are acting as expected. If so, save the program and move on to the next activity where you'll learn to reconfigure this circuit to get a 5-volt input from an IR obstacle sensor. If the circuit or program are not behaving as expected, shut down the Pi and recheck all wiring and the integrated circuit's pin 1 orientation. If everything looks good on the circuitry, then proceed to reboot the Pi. Double check your program. Do not continue until the next activity until the program and circuit are behaving as expected and you've saved a copy of the program.